Hello, this is to introduce this tool, icpc kattis-docker. So this is hosted off of GitHub. If you go to www.github.com/icpc/kattis-docker, it's a public container. You can get it without using any other permissions. And the problem it solves is to set up a context to allow you to use the official versions of the compilers and judge tools so that you can contribute new problems to the Kattis system or participate and be confident that the code that you write will actually behave the same way on your system as it will once you turn it into Kattis for a solution. So the first step in getting this done is to go ahead and just clone this repository, which I'm going to do. So do that copy. So here I'm going to go ahead and do the clone. Actually, so cd, I like to have my projects under projects. I'm going to clean off my last version since that's the step you wouldn't have to do, but since I've recently cloned it. Your command is just git clone and then the corresponding address. I'm a fan of SSH. So I just cloned the project, and now if I go to kattis-docker, that folder now contains a local copy of the project. So that's the first step, is to just clone it. The other important step, I guess, as a prerequisite is to actually have Docker itself installed and configured. So for me, that's this little whale up in the top corner. I have Docker is running and preferences and that sort of stuff all set up. But in the end, I need the container tools to be able to run the components in this pretty convenient, isolated way. To do that, there's some links off of the README file for the project to see how to get that all set up. So I'm certainly assuming that you are running in a place where that container setup works. So that's certainly a requirement. So I've got the project, I've got Docker, runs here. So I just set it up like that, and here's our options. So setup 0, get Docker set up. Step 1, clone, we did that. Step 2, just do the setup. The simplest thing is just to run bin setup in the project. There's a couple of other options. They take, I'll call them special. The simple thing is just to run the setup. Slim avoids the LaTeX version of the containers, which is one of the larger container components, which you would only need if you are creating new problems. If you're not creating new problems, you can avoid that larger container just by doing the -- slim to the setup option. I won't. For me, because I've done it before, it's very fast because all the components have been cached for me already, and so it just says it's up to date and I'm ready to go. So I do get a few containers. This first one I wouldn't get if I asked for the slim option, and this is the overall container that has the LaTeX problem tool components in it. But then these other containers, the GCC Slim, Java Slim, all the Slim containers, are just for the languages specific to the contest and avoid as much complication as possible to just make those compilers available without extra dependencies, which allows them to be smaller and easier to maintain. The important thing for you is that they exist and you can just have them. Okay, so the setup was made. So now, if I look at my GCC compiler as it stands, I end up with, GCC dash version. If I look at the current GCC compiler, it is the one that's part of the Mac runtime. So I get Xcode and C++ 421. So this is the GCC version provided by the Mac OS runtime. But if I adjust my context by just doing dot, that's important, context, and there's a space there, so dot means into the current terminal, incorporate this new context. And now if I look at my path, that the beginning of the path is this current directory. So projects kattis-docker bin. This bin directory now has new components. In particular, if I run GCC and I ask for the version again, I get a quite different answer now. Instead, I'm running this GCC Ubuntu 7.3 just from the regular old Mac command line. So now I can go to wherever my projects are. So for example, CD projects, CD NA Rocky Mountain. This is our current problem set for the Rocky Mountains. So if I go into problems and driving lanes, for example, so submissions. Okay, so here's the submissions. How about accepted? So if I'd like to compile one of these, I can just run GCC-O driving lanes. This is just using the command line version. And these can be built into your editor if you want to, so long as the editor is run after the path is set. It should find the tools you want. The other way is to just explicitly go directly, completely to the directory, and it will run whether the context is set or not. So bf and then driving lanes dash bf.cc. Oh, and that's C++. So run the C++ compiler on that, and wait a moment. Okay, so it compiled it. I can't run it, at least as a Mac application, because it's not a Mac application, but it was built using the GCC container. So GCC-container. Oops, sorry. So GCC Docker, if I want to use that container, I can now run that, and I have to provide some input. So I think I have to go back 2 folders to get to the data, and then samples, and then driving sample. Oh, 1.in. So I'm running in the container suitable to actually run that executable. So since I use the GCC compilers, it'd be the GCC Docker. I run driving lanes there, and I provide input using the sample data, and then there's the output. So hopefully that's the same as the accepted answer, but for the moment what matters is I can compile and run my application on the container, which gives me the same versions of the compiler that Kattis uses. So I can do other useful things. So as a judge, here I am in the problems right here. So I can do verify problem like driving lanes, and it will actually go through and verify the problem statements. Processing pages. That's running the generation of the LaTeX document, and then it goes through and compiles and runs all the solutions and verifies that they are also correct according to the data set that was given. It runs all the validators, etc., etc. So it's just taking a little time because it's kind of a bigger problem. So I guess I'll let it sit in the background and work on that while we go look at what other things might be useful for you. So if I look in here, the other resource you might find useful is under the tests. Here's some unit tests, basically, or just component tests to verify that each of the components seem to be operating as expected for the containers. So those are useful if you just want to run them. It'll verify that they're all working. This other subdirectory called compile underneath the tests has what might be a pretty useful, oh, there it is finally. So it just ran through all the tests, checking the statement, validators, all that worked, and required essentially no configuration on my part for trying to get LaTeX working or all the right versions of the GCC compilers or the Java compilers. is all using the same versions that that will be used for the Caddis official judging of problems. Okay, so jumping back to here to our test directory, these are some simple tests to just validate the versions of the compilers. But the make file is useful because it encodes the what is in the documentation for how the compilers will be run. So if I, for example, in here type make gcc test in that directory, notice I have gcc test.c, so a C source code. If I run make in there with the proper context, it actually runs it using the, oh, I did not accept that. Library not found for LCRT0. Really? Oh, because I made a new window, I never set the context. Of course. So I'm running the wrong compiler. Let me try again, setting the context. So just to illustrate some choices in here, I don't actually have to set the context if you're trying to put this into your IDE and you just want to explicitly run some rules. You could just go directly to the rules inside of the bin directory of this project. So bin make gcc test. So that is all mapped inside of the compiler or inside of the container so that the right tools are being used. And so you can just have explicit paths if that's how you prefer, or you can context in the root directory, just source the context, and now I'll remake it, otherwise it won't make anything. So now it'll run the make compiler, but it'll run it inside the container, and so those things are now mapped to the Ubuntu tools with the right options that Caddis likes. So you can either put explicit paths like this, like inside of an ID sort of shortcut or hotkey kind of idea, or if you're willing to set the context before launching such a tool, then just the standard make and GCC and things like that will work and allow you to build the things that you're after. And of course, you can copy this make file around to other places to run on the tools you want. The other nice thing about this is if the make file happens to make some quick Java test. So if I make Java test, which is based off of that Java file, not only does it compile it, it also makes a small source or a small launch script, so you can just run Java test, and it will launch Java using the options of Caddis. These extra options get passed over to the JVM, so that it runs more or less the same way as it would in the context of being judged. It can't, of course, duplicate exactly the CPU speed or the RAM requirements or the RAM available on the actual machine that it's being judged on. But otherwise, it should be the same down to the minor version of the compiler. So I hope you find those tools useful, and you are most welcome to give them a shot. Thank you.